Let's briefly talk about atomic theory. Atomic theory was proposed by John Dalton around 1800, and he said that everything is made up of atoms, and each element contained its own atom. Atoms of different elements were different. And he said that atoms from one element cannot be changed into atoms of a different element. So there was no philosopher's stone or where you can change lead into gold. And he said that matter could not be created nor destroyed. That actually came from Antoine Lavoisier with the law of conservation of mass. Also, the law of definite proportions. Compounds are formed when atoms of different elements combine. A compound always has the same relative number and kind of atoms. And compounds combine in small whole number ratios. So a 1-to-1 ratio or 1-to-2 ratio. You won't get a 1 to 0.75 ratio. That's called the law of multiple proportions. 100 years later, after John Dalton's atomic theory was proposed, that is when scientists started to probe into the atom to see what atoms were made of and did they have smaller particles. The electron was discovered first with J.J. Thomson. He had a cathode ray tube and he was able to determine that these particles are negative, and he called them cathode rays. Later on, they were named electrons. His student, Millikan, did an oil drop experiment and he actually quantified how negative the charge was. And it was given the value of minus 1.602 times 10 to the minus 19 coulombs. And he also determined the electron's mass. Super, super small. That number there is in grams. Ernest Rutherford next came along, and if there was a negative particle, he tried to find the positive particle. And it was determined that the positive particle is found in the core of the nucleus, and it was named the proton. And it had the exact opposite charge of the electron. Now, these numbers are really, really small, this minus 1.6 and the positive 1.6. And because they have equal but opposite charges, we just make things easier and we say the electron has a charge of -1 and the proton has a charge of +1. It's a relative charge. Ernest Rutherford's student, Chadwick, he later on discovered the neutron particle. That was around in like 1932. So it took a while to find the neutron. It was found in the nucleus and it was hard to find because it was neutral. So here's a picture of some historical models. So John Dalton around 1800, just these spheres that can't be divided. Then J.J. Thomson, he imagined this blob with positive negative charge and he called it the plum pudding model. If you imagine a raisin cake, that's what the English call plum pudding, but that's what he imagined. And then Rutherford, he discovered the nucleus and it had a positive charge and it had the proton in the nucleus. Niels Bohr, we didn't talk about him, but he discovered energy levels where the electrons would be, and Rutherford also discovered that the electron is outside the nucleus, but Bohr showed where that electron was, certain energy levels. And then we have modern day quantum mechanics or atomic theory. Schrodinger, he talked about that electrons are waves and that we have probability areas of where we will find them. But as far as knowing the path of an electron and exactly where an electron is, we don't know that. We have a 90% probability of where we would find it in these certain energy levels outside the nucleus. And so that is called quantum mechanics. And that is our current model of the atom today. The periodic table, the origins of that come from Mendeleev. He was a Russian scientist and he took all the known elements known at that time and he put them on 3x5 cards or a card, and he did a little card game sort, and he tried to put like groups together, and he was the one that first published the periodic table that led to the periodic table we use to today. Mendeleev organized his periodic table by mass, and later on a young scientist in his 20s, Moseley, in 1913, he did X-ray crystallography where he shot X-rays at the elements, and he was able to do a lot of math and figured out that the periodic table would best be organized by number of protons, or what he called the atomic number. The periodic law says that the properties of the elements are a function of their atomic numbers, meaning that they're organized by protons and also by reactivity. So as you go across a row, Mendeleev started a new row when it seemed the element's properties matched. When you go across the periodic table, that's called a period or a row. And when you go down the periodic table, that's called a group or a column. And it's also known as a family. As far as getting around the periodic table, you can number the columns across 1 through 18, and you can number the rows 1 through 7. Also, on the periodic table, another way of numbering them besides 1 through 18 is you can use these Roman numerals. So 1A, 2A, and then down here, these are the B series. So, and it starts with a 3B, which is a little bit weird, but we'll explain later. So 3, 4, 5, 6, 7, 8, and then 1 and 2. And then our A series continues over on this side with 3A through 8A. And I prefer the Roman numerals ways because that tells you the valence electrons, at least for the A series. So a valence electron are the outer electrons, and there's 1 to 8 outer electrons. You should be familiar with the families of the elements, so make sure you stop this slide and take notes of what the family names are. So there's alkali metal family is the first column, with the exception of hydrogen. So hydrogen is its own family. It's kind of an orphan. And then we have the alkaline earth metal family is the second family. The elements in the valley, those are called the transition metals. And then the next columns are named just after the first member of the column. So the boron family, the carbon family, the nitrogen family, the oxygen family. The family that starts with fluorine, that is called the halogen family. And then last but not least, we have the noble gas family. There's 2 rows down below that have their own name. So this is a period that has a name, and it's the lanthanide series and the actinide series. And actually, these should fit right here. They've actually taken scissors to the periodic table, and they have pulled down these 2 rows down to the bottom. So this row should go there, and that row should gets extended out there. So here's a picture of it extended. So you can see that how the periodic table is formed when we have this repeating periodic properties is that it should be very, very, very long. So if you look at this, there's a lot of empty space. So what we've done is we've just taken scissors and we've cut this out. We kind of cut it out weird though. We cut it out right here and right here, and we've pulled it out and pulled it down and then scrunched everything together. So this very first member, lanthanum, that is the first member of the lanthanides. And the last member is actually a transition metal. So they just kind of cut it funny. And then the actinides starts with actinium. And then you should have little stars that say, hey, go down below. And then you have all the actinides. And the very last one is a transition metal. The parts of the atom, you should have learned this in 8th grade. So in the nucleus are protons and neutrons, and your electrons are outside the nucleus. And they are not in orbits, they're actually in orbitals. And these are areas of probability of where you would find them outside the nucleus. So there's a region where you would find the 2 closest electrons, and then a region where you would find the next 8 electrons.